This is Team 12B presenting you our mini project, real-time tracking and monitoring of vehicles using computer vision and web development. Here, we create a system to track your vehicle. It is done by identifying the license plate through CCTV using our image recognition model and updating him in the database. And now a software comforts traffic officials, government investigation, and even the vehicle owner by giving them the timeline of your vehicle visiting wherever it is found. Our project mainly focuses on enhancing the recognition and reading the number plate. It combines advanced techniques to give the accurate results. It uses inception resolution network V2 network, and it uses OCRs like easy OCR, Keras OCR, and paddle OCR to get the accurate number out of it and YOLO weights. So in the existing system, the number plate recognition is slow and it cannot be detected in the dim lights. And our project can overcome that. And uh, the accessing of the timing of your vehicle, even though if it is there, it is only accessible by the traffic police and the government officials, not for the owner. And even the tracking of the vehicle, which got kept is done manually. Like you try to identify all the possibilities where the vehicle has gone rather than focusing on its path. So our project helps you to track the vehicle by giving its timeline so that you can directly track where it was last found rather than checking every location in its camera. And our proposal for this is that identifying the license plate image using the recognition model. Our recognition model uses Inception Resolution Network version 2 for capturing the region of the number plate, and it uses Easy OCR, Keras OCR, and Paddle OCR, and get the best value out of it. Means best license number out of it, and it is going to update it in the database. We use MySQL database for storing all the vehicle numbers, and we did it in such a way that every uh, license number has its own table, which consists of location, time, and date. And whenever the user gives his input to the website, that is his number plate, that is his license number, it gives him the complete timeline where the vehicle was last visited, which makes him easy to track the vehicle. And now, to illustrate the functionality of our system, we have prepared a use case diagram. It demonstrates how various actors interact with our system and how the action is performed. And now this activity diagram that helps you to visualize the flow of activity within our system. It showcases the sequential steps involved in the real-time tracking and monitoring of the vehicles. So first we collect the data, then labeling of the data is done. Then we try to convert pass this XML information into the CSV file so that it is easy for the training. And we try to verify our data and pre-process it and split the test and train data. And then we pass our train data to this Inception ResNet V2 model and create a pipeline which can give you the region of interest, that is the region where the number plate is located. And by applying the OCR, it's going to generate the text and update it in the database. And now this is our deployment diagram. We have a deployment diagram that depicts the hardware and the software components that are used uh, for the system deployment, and it provides the overview how our system performs. Here, the user performs the exploring task and the image processing task, and the application is responsible for training it using the resolution network model, and it's gonna take the number plate region and it's gonna give the text by using the OCR. And now let's move to the data flow diagram. It illustrates the flow of data within our system, showcasing the input processing and output stages of the number plate region and monitoring process. A sequential diagram further demonstrates the sequence of the actions and the interactions between different components of our system. It provides clear understanding of the real-time tracking and monitoring process. And system architecture diagram gives you the overview of the system overall structure and the interaction between its major components. It showcases how Inception ResNet works and other modules work together to achieve the accurate number plate recognition. And now there is the implementation. So if you upload the number plate, if you upload the image of your car, or if you upload a video, it's going to give the list of the number plates which are recognized in that particular image or a video like this and update it in the database. And so when a user queries gives his uh, license number in the website, it's going to give him the timeline like this, the serial number, date located, time located, and the place where it is located. And this is the execution. I'll show you a demonstration. So what happens if you upload an image? Like what happens if you put an image into the database and see if I put this, if I put this image, I'm gonna get the number plate, license number or license number of the vehicle. And next, if I upload this image, like this one, if you observe, even in the dim light, we are able to recognize the text over here. So this model is working perfectly. And now I'll show you the user interface, how exactly a user can can get his vehicle locations and at what time and he can so that he can track his vehicle faster and easily. So I'll show you. Let us see this number AP 39 HHA 5441. On submitting, see this is the a date and the time and the place where the vehicle was last visited, like where it was last found. And now if I say like this BA09 2191 and submitting it. See, this is the timeline where the vehicle was seen last. So the main motto of this project is that, rather than searching for every location in the city to find a vehicle, you can simply track your vehicle where it was last visited and search in those areas. These are the requirements of the software. The hardware requirements are a simple Intel processor and a camera, and the software requirements are libraries like Pandas, Video, OpenCV, TensorFlow, NumPy, and the programming language which we use for this is Python and HTML. And we even use the web framework that is Flask for creating the web page. And the database we use this MySQL, and the operating system in which it was built as Windows. This is our team. Our project guide is Mr. K. Sandeep, Assistant Professor GRIT, and our team, myself, Gaucheru Nitin Reddy, and Fedaprolu Ramapavan, and Janakam Pranit Reddy. Thank you.